Hello and welcome to the ThinLinc HPC community webinar. Today we are going to watch the presentation Interactive Supercomputing for Research at Purdue University with Kevin Colby. Are you hearing me?
Yes.
Great. So thanks for joining this session. I see that we have people from different regions, Europe, South America, North America, and other regions that perhaps I didn't mention. Thank you all for attending. So people are still joining. As I see the list, the number is growing, but we can perhaps start. So everything started in February 2020 when a group of academics submitted a BOF proposal to ISC 2020. And they had a common interest for HPC and a wish to discuss the topic interactive supercomputers. The plans for ISC changed, however, the interest in the topic remained. So as a consequence, the HPC webinars are now happening, and we want to express our gratitude for their effort, as well as for the effort of the other presenters, Bernd Daman from DTU, Robert Henschel from Indiana, Anders Folin and Jonas Lindemann from Lund, and today, Kevin Colby from Purdue University. So the title of the presentation, again, Interactive Supercomputing for Research at Purdue University. We have here the abstract for the presentation that was already shared with all of you by email. Kevin Colby, our presenter, he is Manager of Research Support at ITap Research Computing, Purdue University. And we have a short bio from Kevin, and I think he will present himself with more details. Right, Kevin?
Not really. Plenty of detail. Nobody came here to hear about me, but if you'd like to talk about me later, that's fine.
Great. So, some instructions here. The estimated total time for the session is 60 minutes, being more or less half of the time for the presentation and demo, and half of the time for discussion. If there is an interest in continuing the discussion after the 60 minutes, you are welcome to stay. This session is recorded. However, it will only be publicly shared once Sandu has the express permission from everyone that has been active in the session. So the first part, the presentation, we invite the audience to turn off the microphone. The aim is to reduce noise pollution, and remember to take some notes and save your questions for the discussion. But as I understood from Kevin, in this case, he's thinking on asking questions during the presentation, so perhaps you can join even during the presentation. Your active participation is welcome and enriches the discussion. You may contribute directly or writing down in the chat. So remember to turn on your microphone when asking questions, and if possible, introduce yourself briefly. Yes, so Kevin, now it's with you. I think I'll stop sharing my screen here.
Okay.
Are you ready?
Yeah. Where is the share? sharing anything?
There is a white screen.
Yeah. Let's try bringing this up first. It didn't offer me the chance to share the thing I want to share. Ah, there we go. Okay. Now you see it?
Yes.
Yep. Okay. All right, I'll continue. Hi, everybody. I'm Kevin Colby. I've been at Purdue for quite a while, in research computing for quite a while, and in a lot of different roles. So I'll just kind of leave it at that. Purdue, in case you don't know, is a little far from Sweden. I tried to show where it's at a little bit. You can see it's a bit of a jaunt. We're over in Indiana, in the central US. Ironically, close to one of your previous presenters, over just down the road from us at IU. So Purdue's a lovely campus, and let's see, let me minimize these people here so that I can get them out of the way of my screen. Okay, and founded in 1869, and it's a relatively large campus. Well, we have, in fact, 4 physical campuses across the state, 60 some odd thousand students across those, a bunch of different colleges and schools, and more importantly, we're pulling in about $500 million in research awards each year. So research is a very much a big thing on campus. So research computing at Purdue has a very long history. It currently is a division of ITap, which is the centralized IT organization at Purdue. But we grew from prior incarnations of various groups on campus, going all the way back to 1967 when we got our first control data corporation machine, 6500. Which actually is currently running and available for you to check out at Paul Allen's computer museum out in Seattle. He actually bought the thing and restored it, so that's kind of cool. From there, we grew and did a lot more computing, and a lot more computing, and a lot more computing, and a lot more computing, even recycled clusters, which were big for a time, and then a lot more computing. We eventually settled on community clusters. So this was sort of one of the early condo models when basically there wasn't central funding to continue just giving away cycles, and we needed to get the faculty to have some skin in the game so that they could vouch for the validity of what they were doing. This was really good, mainly because it removed us from the terrible position of having to judge people's science. You know, who gets priority on a system, or who gets on a system or not on a system, is really not something that IT have any business judging. And by even pushing some sort of a subsidy through, we were able to move that to something that then is judged by the peers of the scientists through the grant process. And we think that's really great. And it actually removes a lot of the concerns that we would get from scientists. So in the end, I think everybody likes it better. Here's some details about how we run our condo model, but we don't need to get into all that. A lot of that was discussed by some of the previous presenters you've had. The gist of our program is that we've been running that basically since 2004. We built about 20 major systems, 9 of them on the top 500. Soon, I hope to be 10. We just finished benchmarking yesterday, one of our new systems, Bell, and I think it came in at 1.6 petaflop. So we're feeling pretty good about that, making at least somewhere on the list. So last year we delivered 350 million hours, and we've got about 200 active faculty partners across campus from different departments and all different colleges and campuses. So we try to be very broadly used. That's not all we do, though. We also have a fairly large instructional cluster called Scholar that gets a lot of use by classes that are teaching early research methods and tools and technologies. And that's been very, very successful. We also do storage these days, sort of pay by the terabyte year additional research storage beyond your scratches and things that kind of come with the cluster, but for something permanent. We also do data visualization. We have a center down in Stewart Center for doing that. And of course, expert help and consulting, which we do all the time, including coffee hours where we go out and we used to physically go out, and now we have to virtually go out 4 days a week to try and meet faculty where they are. Purdue's IT landscape is a little complicated. We have a central IT organization, that's ITap, Information Technology at Purdue. It's got almost 400 staff and does all the university-wide and system-wide stuff. But there's also a bunch of different academic IT organizations around campus that operate independently. And those are organized, embedded within their colleges and schools. And that's good for them because they really have a better pulse on what their faculty needs are. But it does mean that we have to have a lot of cooperation, communication, collaboration across the university to make all this work right. And that can be a challenge at times, but ultimately I think is fairly effective. So an example of that is I was coordinating with someone from ECN about this, Andy Sedelko, who organizes a lot of the ThinLinc use in ECN today. They started off with Sunray Tech in 2005 and then eventually moved to ThinLinc in 2013. But they're today supporting about 500 concurrent sessions over that and across 8 servers, various ages. And that's wholly independent from what we do. So we have a variety of use of things like this around campus and by a variety of organizations in using it in their different unique ways. So, but why interactive? Like, why are we doing this? And ultimately, it comes down to a few realities. There's really limited growth in the traditional HPC user market. We have to look at where can we expand into new areas, and when we look around, there's just not a lot of people learning that. The sciences that are into that are great, but the other sciences aren't. There's a lack of understanding of command line interfaces that goes very deep, and while I think Vern, your first presenter, lamented that this is an ongoing problem, but I don't think that it's really going to improve. I think this is just a reality that we have to accept and figure out ways around. And of course, the expansion of computational models in the other sciences. That's really one of the biggest things driving this, is that for a long time, a lot of the other sciences were able to get by with computing that's readily available on their desktops or laptops, or at least maybe a major server in a lab. And a lot of those other sciences are now getting into more complex models or AI or something like that, where it's just not enough anymore. And they need to get into some bigger scale computational resources. And that's a great opportunity for us, because we're all about science. That's the whole point. We're here to further the science, and more science and more science and more science and more science, because we want to meet the scientists where they are and just help them get the science done. They don't care about technology, and they shouldn't. So interactive computing is a lot of what they want. So why can't we just give it to them instead of trying to teach them a different way of working? Well, if you want to go beyond just a terminal for a long, long time, you had really one choice, and that was X. And I think there's mostly a technical crowd here, so we probably know all the problems with X, which are numerous and varied, and right down to the fact that even the servant-client nomenclature in X feels backward, at least to any user that you're trying to explain this to. So that was always a problem to get right, and some things made it a little better. I know MOBA Xterm tried to bottle it up for us a little bit, but ultimately this was never going to be a tech that we were going to be able to get users to use successfully very well on their own. You saw proliferation of science gateways in trying to deal with this. But as Robert mentioned in his talk, these are very focused on usually a particular scientific domain in one respect or another, or some specific subset of tools, and may require bundling up those tools and wrapping them and presenting them in web interfaces and other kinds of work. So while that was great, it had only impact in those niche areas. Some of them did try and offer a more generalized workspace app using basic VNC, but this could be a little rough around the edges, to say. And even Robert was lamenting in his talk about, we really don't want to be rolling our own kind of stuff here if we don't have to. So what to do? Well, we came upon ThinLinc, and I'm not sure exactly when we first installed ThinLinc, or if we got the idea originally from ECN or from IU. We looked a lot at what IU had done with their Cars desktop in the very earliest incarnations, and we're really, really excited about it. So much so that we immediately thought, we've got to do this, and we've got to do this not just for a sort of a one-off thing, but we should really embrace this across all of our clusters and make this sort of a standard offering. Well, our clusters at the time, we ran Red Hat Enterprise, and we were using Moab and Torque from Adaptive and Puppet to manage our systems. That's changed a little bit. Rel's out, CentOS is in. We've also moved from Moab to Slurm, and we added XCAT and did this kind of hybrid XCAT Puppet thing that's ended up working out actually a lot better for us. And all that drives a fairly straightforward cluster model like you might be used to seeing. We have people on laptops, the SSH to front-end nodes, which are slightly different hardware configurations from the worker nodes that you access via the job scheduler. And that's a pretty typical HPC workflow. So what does ThinLinc do? Well, ThinLinc changes it by just adding a different way to get to that front end. Now the user can just log into a graphical interface, and they can pop onto the front end, and they're there, and now they can issue jobs normally or do any of their other work. This had a lot of benefits beyond the graphical. Being able to preserve your sessions, I think Robert mentioned this some, is really huge. Users just love this. It sort of serves the same role as something like Screen, maybe in the command line days, where you could not worry that your network's going to get blipped, especially since most people are on laptops, they're moving around, they're getting bumped from one access point to another, or perhaps from whole different Wi-Fi networks. And we don't want that to break your work. So now they don't have to worry about, how do I set up Screen or prevent things from breaking when I disconnect. They can just use ThinLinc, disconnect, and they reconnect, and it goes right back. And they absolutely love this. Now, there's limits on how long we can keep the sessions open for other reasons, but that's been a huge, huge win with the users. There are some problems, though. C groups is a necessity if we're going to be offering this sort of freewheeling access on our front ends. And we worked actually a lot with IU and figuring out how they had tried to configure this, and we've done a lot of further work trying to configure this, but this is definitely sort of a moving target. We keep having some limits that are dynamically adjusted and some that are fixed in various ways based on various things. And and tweaking this and trying to still track down the occasional user who manages to somehow slip around all this and cause real memory problems on the node or something like that. So that's an ongoing issue. We were a lot of concerned about how two-factor would work out. We had to implement Duo two-factor on relatively short notice, and in spite of that, though, it went quite smoothly, and we have that working fairly well, at least as well as it could. So kudos to having a product that's ready for that. I did see that IU had some contributions early in the days of trying to get that working that may have smoothed our transition there. So if so, thanks. There's a lot of other things going on here, like these days, HPC, more generalized HPC portals that are sort of maybe subsuming some of the mantle from the more domain-specific science gateways. You've got Jupyterhub, and we do support Jupyterhub on all of our systems as well. ThinLinc is not the only graphical access that we offer these days. We also offer our Studio server, which is another system, and that is very similar, but is really oriented around R, sort of the same way Jupyterhub's oriented around Python. And finally, OpenOnDemand, which is a new offering. It's being developed by OSC and is probably going to be tightly coupled with a lot of the Exceed offerings, if you're familiar with the Exceed consortium. And it is trying to be a more generalized HPC web portal. So launching HPC applications directly, configuring batch job submission scripts from the web browser and then submitting them and things like that. But all of these are sort of nibbling around at the same problem. And that's that we have a large spectrum of need. We have stuff that goes all the way from basic laptop need to, okay, we need something bigger. And one of the things that we really tried to do here is focus our offerings around providing things all along this spectrum. So we have the more traditional HPC things all the way at the right that offer lots of nodes and lots of compute, and you have to use MPI and get your Slurm submission right and do all of that. But we also have a lot of the people that maybe just needed a node or two and just were doing sort of simple parameter sweeps. So we certainly support that. They get a lot of use from our standby queue system, but we have the people who maybe they don't even need that. They just need something bigger than what they're able to access on their desktop or on their laptop. We stood up a system called Workbench specifically for that, which is basically an HPC cluster without the job scheduler and the nodes, which might seem a little strange, but it's just the front ends. And so all it offers is that same sort of live sharing experience of using something a little beefier hardware that you can access over ThinLinc or any of those other products, Jupyterhubs and SSH, of course, is still supported. And you can get into something that might get you that next step. It's a good transition then for users to move from that to one of the more batch-oriented systems, because all the software stacks are the same, all the access mechanisms are the same. All the other things that they've gotten used to about those systems are going to be exactly the same, except now you have more nodes and you have a scheduler. So that's all I was going to real quickly try to run through talking, but I was going to perhaps try and show some things live. I know that's super crazy and dangerous, but what the heck. But perhaps if anyone wants to stop me before I get into something like that, and if there's any questions already, I'm happy to answer those. I'm actually not sure exactly what we have installed on all the front ends. So we have GPU systems that are more geared for, like, if you're really doing GPU type stuff. And those will offer various, server level kind of GPUs, voltas and things like that at the node layer and at the front end layer, because you might be using those for viz things, or you might be using those for just shaking down your code that you need to submit to the nodes. So I don't know if that quite answers your question. Mostly, if you're doing really heavy viz stuff, you might be talking to our visualization lab, and they have some other options. I will say that I forgot to mention that the things like the GPUs and whatnot fit into the spectrum too, because we have a lot. Perhaps it's more of a landscape than a spectrum. You have the people who need GPU acceleration, especially with AI becoming much more of a thing these days. Okay, I lost the share when it flipped windows. You back? So you can see this is our welcome message for logging into Brown. And then boom, I'm on Brown. And of course I can do basic things like start up a shell, but that's not very interesting. More interesting is like actually starting things like cluster software and things like that. So you can fire up a MATLAB window, just running MATLAB on the front end. Like this. And there's a bunch of other applications that we could try and access from in here. We also support trying to start some of these things through jobs. So if you want to fire up MATLAB on a node, I can fire that up. Say I want to get access. I'll try and pick the standby queue. See how quickly that'll get me scheduled. Pretty quickly. And this one is running actually on one of the nodes. So I can find my shell wherever that went. I should be able to see that. In fact, I am running that job. So any questions about any of this or anything people would be curious about? So it's a mix. So the front end nodes and the compute nodes both are getting their images initially from XCAT, but then when XCAT starts up, then we have Puppet running behind that. So Puppet may make a few more changes after the node image comes up. The node images are also built by Puppet, so it's a little complicated there. But once the nodes are up and puppeted, a lot of the application software, though, the sort of user level application software, things like MATLAB or Gaussian or any sort of scientific code, those are actually being built by SPAC now, and they're being deployed with LMOD. So users have to module load the correct module from LMOD to get the right environment set up so that they can then start the application, the scientific application, if it's a software that we support and maintain. A lot of our users actually build their own software, and that's totally fine too. And obviously, they do that all kinds of different ways. So that is still hard-coded to manually test each of these and decide what we want to put in here. That's actually, this menu and the desktop itself is a place where I think we have a lot of room for improvement. We could really spruce this up, add a lot of things, and support a lot of things more directly than we are. And ideally, we'd integrate it directly to LMOD so that we could simply somehow, query the LMOD tree and auto build these things. But we haven't gotten that far. Windows 10 launches as a QEMU. Yeah, so we can actually, let's see, I might have, do I have a saved image hanging around? I don't know if I have a saved image hanging around. Well, I'll start that and then people can ask other questions while it thinks. I did not do that myself, and I'm not sure if that was done there or directly through editing the backend files. We would prefer to just edit backend files because we would like to integrate it into all the LMOD stuff and things like that, which would obviously be much more easily done that way. So the Windows VM is able to access some of the underlying storage systems and get those mounted. So it's able to access some of the things that we make available to the underlying system, such as your Scratch directory. On most of our clusters, that's somewhere in the like 100 to plus terabyte temporary storage. And then we also offer, sort of paid, more permanent storage on Depot, as well as a permanent data archive for people on tape if you want to just shuffle things off there. I'm not sure if we built that in. I think we just coded that to request the max for the queue. That's obviously not ideal, but that's what that does. If you look at a product like OpenOnDemand, you'll see that when they launch jobs, because they're more integrating into the scheduler, they do ask some of those kind of questions before they launch things. I'd love to be able to have this be a little more customizable, but it's not clear what the best way to do that is. By and large, we figure that the people that are launching things this way maybe aren't going to be doing a lot of customization. So it may be okay to some extent to treat your population as a little bit, bimodal there. No, it is a general product, and configuring it and getting it working is something that is up to you. It's just an open source product. So what we've seen is that ThinLinc seems a little bit more polished at present, and it's a little easier to use, and there's some advantages to the having a real app. So OnDemand is entirely in the web browser, and so that limits it in certain ways. Obviously, ThinLinc has a web client and is probably well aware of some of the limitations there. But also, their focus really started with a sort of a front end to a batch system. So it's really trying to front end your HPC traditional systems into a web interface. That's the sort of the original design goal behind it. So you can use it to do some things like this, and you can even use it to try and launch a desktop, if you will, but that's a little complicated at present. And that's one of the things that we've been looking at is what are some of the ways that you could get around the fact that it always expects you to be working through a batch system and launching jobs. And one of the issues we're grappling with is just user preference. If one product is a little bit more polished in one way or another, how do we deal with that? We have a lot of users who have really loved using the R Studio for R, specifically for teaching R. There are other ways you could start R, but I'll mount the Scratch. That was the what file system I'd like to access when I pop into Windows. But when you, I'm sorry, so about R Studio. So, but it's a little different to operate and offer some challenges on the back end to admin. So, can we offer, the other ways of accessing R? Yes, but they're slightly different. And will that hurt your acceptance rate with users, or I don't know. That depends. Ultimately, we really want as high of an adoption rate as we can get. So we try and walk the line between doing what is maybe technically sufficient and what users really want. I mean, we could say that it's technically sufficient to offer X11 and SSH, and that's it. And you could do all of the things that I've done with just that. This is just a brand new Windows Server installation. So like never been used, basically. So currently we don't provide a lot of Windows software. We just don't have a lot of Windows software users. And to a large extent, they provide their own or have specific things they're interested in. So what I can do is I can manipulate this. I could install something and set up things, and I can save this and relaunch the next. So that long delay was me copying and building a new image for myself. Now when I relaunch it, I can say, hey, just load that saved image. And that'll be much, much quicker. And it'll also contain all the changes that I've made. So if I've installed software in here and configured things, that'll also be here. If nobody has any other questions, I'll just leave this up and people can chat or do whatever they want. I don't know, John, was there anything on the chat? I haven't been looking.
Hello. So yes, all of you are invited to ask your questions, whether using the audio microphone or writing in the chat. So feel free. From now, Kevin, there is no question yet in the chat.
Okay. We have, and we actually back to the spectrum. We are in the process of standing up a new resource that's really dedicated around Kubernetes containers. So, like not containers, but Kubernetes and Rancher. So that is going to be sort of our first major exploration into that space. Thus far, the C groups thing has worked out fairly well for the front ends. And on the nodes, we don't allow sharing in that way. So they're fine. They're locked down with a PAM filter that prevents only the Slurm allowed user for the job that it's running to be on it.
Okay, it seems silence remains in the room. Last call for questions.
Well, if we don't get any, I want to make sure before people sign off that I thank them for coming here. And thanks to Cindy for inviting us.
Yes, I think I will share my screen here.
Thanks, Kevin.
Yeah, thank you. That was very, very interesting. Thank you.
So let's continue here. Discussion, as I see it's concluded now. Thanks all of you for joining this webinar. We hope you had a good session, and we asked the question, would you like to present your ideas? You are welcome to join the community and share your thoughts and feedback with us. So there is the email aaron@sendio.com and also jeanzagonel@sendio.com. You are welcome to share your experience. And Kevin, thank you very much for your time, for your presentation. Hope you had a good session as well.
Yes, you're welcome.